All right, 57, kind of a fun little problem here. Now, really what this problem comes down to is the fact that you can integrate the function f of x equals the natural log of x using the method of integration by parts. And that's kind of a surprising realization to a bunch of Calc 2 students until they see it done. As a reminder, integration by parts just tells you that the integral of u dv is equal to uv minus the integral of v du. The reason this typically surprises students is because they think about using this when you have something times something. And if we're just trying to integrate the natural log of x, you don't really have something times something, you just have the natural log of x. So the trick that you do is you let u be equal to the natural log of x, and then dv is just equal to 1 dx or dx. If u is the natural log of x, then du is 1 over x dx. If dv is dx, then v is just equal to x. If I plug these four pieces of information into this formula, I get that the integral of u, the natural log of x, times dv, which is dx, is equal to u times v, so x natural log of x, minus the integral of v du, so x times 1 over x dx. But wait a minute, x times 1 over x is just 1, so really I'm just subtracting the antiderivative of 1 dx, or just dx. So I get x natural log of x minus x plus c. Typically what Calc 2 students do is they see this method one time, and then going forward they just kind of memorize that the antiderivative of the natural log of x is equal to x natural log of x minus x plus c. So you don't have to rederive this every time. But with this method kind of in mind, we could consider the antiderivative of the natural log of t raised up to the n power. First comment, when they write log on this test, they mean the natural log. To me, this means log base 10. This means natural log. But note, I'm not changing the integrand here. It's just a different way of writing the natural log. Anyways, if I wanted to figure out this antiderivative, I could do the same trick that I did before. I could use integration by parts. Playing the role of u, instead of being the natural log of x, would be the natural log of t raised up to the n power. I've kind of used up everything for u, so dv is just the dt. du is easy enough to figure out. The derivative of this using the chain rule, I bring the n down in front. I got n minus 1 for my new exponent, but then I got to remember to multiply by the derivative of the natural log of t, which is 1 over t. Since dv is equal to dt, v is just equal to t. Plugging this all into my integration by parts formula, I got the integral of u dv is equal to u times v minus the integral of v du. So n times the natural log of t is n minus 1 times 1 over t times this t. But much like up here, when the x and the 1 over x canceled out, down here, the t and the 1 over t cancel out. So I can rewrite the right side of this equation, maybe pulling this coefficient of n out in front of the integral like this. What I've just shown is that the antiderivative of natural log of t to the n power can be expressed in terms of the antiderivative of the natural log of t raised up to the n minus 1 power. That's kind of interesting. If you look at this problem, we're defining I of n to be equal to a definite integral of the natural log of t raised up to the n power. And the idea is to rewrite I of n in terms of I of n minus 1. In other words, rewrite the integral of the natural log of t to the n power in terms of the integral of the natural log of t to the n minus 1 power. That's exactly what I did right here. So let's evaluate all these expressions, plugging in 1's and x's. I got the integral from 1 to x of the natural log of t raised up to the n power is equal to, if I plug in x everywhere I see a t, I get the natural log of x to the n power times x, or x natural log of x to the n. If I plug in 1 everywhere I see a t, because the natural log of 1 is equal to 0, this term just goes away. So this equation in terms of indefinite integrals can be rewritten as this equation in terms of definite integrals. But remember, the problem tells us that the integral from 1 to x of the natural log of t to the n power is this thing I sub n of x. So what I have written right here is I sub n of x, and what I have written right here is I sub n minus 1 of x. I can rewrite I sub n of x in terms of I sub n minus 1 of x. If I just add in the rest of this stuff in purple, x natural log of x to the n minus n times this I sub n minus 1. Take a picture of this in your mind. Come looking for it up here. I believe it's exactly what we have in statement B. I sub n of x equals x natural log of x to the n minus n times I sub n minus 1 of x. Nice.